Hello, this is the next video in a playlist that I'm calling Hypothesis Testing, and we're in the unbiased phase of this big playlist. And we're going to look at a two-sided, uniformly most powerful, unbiased composite versus composite test. And we're going to be in the Poisson setting. Now, the previous video we looked at the sort of theoretical calculations and how to derive the equation that we need to solve to find the critical regions, and now we're going to use R to do that. So the null hypothesis is that the lambda parameter in the Poisson process is between two values, lambda 1 and lambda 2, or is it less than or is it greater than in the alternative hypothesis. So first let's remove all the objects from the list, and the null hypothesis we're going to test, we're going to let lambda 1 be 2 and lambda 2 be 2.5. We're later going to use 2 and 5 because I just love the shape of that power curve. I just want to show you. So we're going to use alpha 0.05, sample size 25. CR stands for critical regions. We find all possible combinations of C1 and C2 that could be part of the rejection region. Then we keep only the ones where C1 is strictly less than C2. Now these K1, K2, etc., you have to watch the previous video on the list. Essentially, we create two equations with two unknowns, and then parts of the equations we call constants, K1, K2, and K3, and that's what we do here. That's part of the first equation requirement, and then K4, 5, and 6 are part of the second equation. Then we solve for gamma 1 and 2, and we keep only the solutions where gamma 1 and gamma 2 are between 0 and 1 because they're a test function. And we now have one observation. This is it. C1 and C2 is 39, 37. Gamma 1 is 6.65. Gamma 1 is 13, so gamma 2 is 0.65. Let's check to see if it does equal alpha. This is the theoretical. And notice that the conditions, the expected value of our test function, given that lambda 1 is a true value, should be alpha, and it is. The second condition is that our expected value of our test function, assuming that lambda 2 is a true value, should be 0.05, and it is. Our C1 and C2 are 39 and 76. Gamma 1 and gamma 2 are this. And then if we plot the power curve, let's see where we are, right here. If we plot the power curve for this and look at it, it's this right here. And notice we're between 2 and 2.5. The power curve is below alpha, which is the horizontal dotted line, and we're always above it in the alternative region. That's why it's an unbiased test. Let's run a computer simulation. Let's store C1 and C2, gamma 1, gamma 2 in their own little variables. Let's do 1 million reps. Let's create a vector of Poisson random variables, a vector of 1 million by 1, and we're going to assume the true lambda parameter is 1.25. Let's see how many times we reject. Let's table them and then divide by 1 million. So it's 90%. So let's look at these plotted on the power curve. We assume the true lambda was 1.25, and we simulated a value of 90%. And look at that, it agrees with the theoretical power curve. Really close. And with the million reps, we're almost ensured that it does agree. Now let's look at this leave out one tell test, and it's so easy to calculate the critical regions based upon this C1 and C2. You just find the area left that's assuming lambda 1 is true, that it's less than alpha, and then you do the same thing for when you assume lambda 2 is correct, and you look at the area to the right, and then you can kind of solve for gamma 1 and gamma 2 from that. Now let's look at the alpha values, and these here, this is it. This is the leave one out test. So we force it to be a 0.05 level test, but it's no longer uniformly most powerful unbiased. It's approximately though, and it's really, really close. The critical regions for the UMPU test is 39 and 76. Same way for the leave one out test. Let's create a power curve for the leave out one tell test. And let's plot the two curves on top of each other and just see how close they really are. And notice that on my screen I can see some red and some black all along this curve, but essentially they're the same. And the leave out one tell test is so easy. You could do it with the 4-function calculator and a Poisson table in the back of a book. You could conduct this test so easily, and it's really close to the optimal UMPU test. Now, as promised, I want to go through the power curve for this other setting, and that is lambda 1 is 2 and lambda 2 is 5. So we're really spreading them out. And I'm just going to highlight everything and let it run, and then look at the power curve. Because I don't know, some reason I love this. I love how the theory works. The null regions between 2 and 5, and the power curve is below 0.05. And in the alternative region, it's above 0.05, so it's an unbiased test. But this is the uniformly most powerful unbiased test for these hypotheses. Well, anyway, that's all I have for this video. As with every program I do with R code, I copy and paste it in the comments. I try to pin it so it stays at the top. And that's it. So I hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.